We are Group 8. Our project was EC3 in a row, and we'll be talking about some of the modules that we designed for our project. Right now, we're looking at the top module for our entire project. As you can see here, it takes a few inputs such as the clock, a reset switch, and then 7 switches that are used as player selection, move, position selection, and an enable switch. And you'll see the output here. We have 2 3-bit registers for each RGB LED, as well as the H-Sync, V-Sync, and RGB for the VGA. You'll see here that the first module that we instantiate is our Ttt Decoder. And what this does is it takes in the 4-bit position input that the player plays. And once the enable switch is hit, confirming the turn, that will encode the player's input into a 9-bit, 1-hot encoded output. So, for example, if the player wanted to play in position 1, they would have to input 0001 on the board, and then that would then get decoded into a 1 leaded by 8 zeros. And if they wanted to play position 2, it would be similar, but it would be 7 leading zeros, a 1, and then a 0 afterwards. And this always block right after that checks to see whose turn it currently is. So if the position, or excuse me, if the player switches is set to 0-1, that indicates it's player 1's turn. So player 1 gets the enable from the decoder. Player 2 gets 0, which basically just means player 1 will take their turn. Player 2 is on standby. And then the other if statement is for player 2. And then you'll see that the next position, the next module we instantiate is for our position registers, which Eric is going to talk about.
Okay, so for the position register, it takes in 2 player enables, which are 9-bit 1-hot encoded inputs, and the registers are updated accordingly based on whether the moves of the 2 players that they choose are legal. And in order to determine whether these moves are illegal or not, this requires us to make an illegal move detector module. And in this module, it takes in the values from the position registers and the 2-player enable functions and uses or statements and statements in order to determine whether that the position they chose is already full. And then we also have the no space detector module, which is going to talk, which uses the position register. It checks every position to see if it is full or not. So if it's full, it's labeled as 1, and if it is empty, it's labeled as 0. And all these labels are ANDed, and the product of these AND statements determine whether there's any space left.
So next I'm going to talk about the detect win module. And if you look at the module, it takes in the 9 position registers as the inputs, and there are 2 bits representing the players, or 0, 0 if they're empty. It outputs a winner, which is 1 bit. It would be a 1 if there's a winner, a 0 if there's not. And it also outputs a variable called who-win. That's 2 bits representing each of the players that could potentially win. So if you look, one of the main features that this module plays on is that there are only 8 possible ways to win in tic-tac-toe. So you could win through either of the 3 horizontal positions. So 1, 2, 3, 4, 5, 6, or 7, 8, 9. You could also win through either of the 3 vertical positions, which would be 1, 4, and 7, 2, 5, and 8, or 3, 6, and 9. And the other 2 ways to win are through the 2 diagonals, which are 1, 5, 9, and 3, 5, 7. And those are labeled there. So this module also calls on detect 3 in a row, which is another module we made, and it calls on it 8 times. And detect 3 in a row will detect if there are full position registers in each of those 8 configurations that could lead to a win. And if there is a winner, that is, if those position registers are filled by the same user, winner would be assigned to a 1, and who-win would be assigned to a 0-1 if player 1 was to win, a 1-0 if player 2 was to win, and a 0-0 if no one was to win, and it would be a tie.
Next up, Seif is going to be talking about our Vga Display Module.
All right, so for this Vga Display Module, this is basically just how the inputs from the switches on the boards are stored into the registers, and then how they're actually just at the end displayed on the monitor through the VGA. So you have your inputs of the clock and reset, and then you have your inputs that are coming out of the registers. So the inputs that are position 1 to 9, which are all 2 bits, those are the contents that are coming out of the registers. So basically 1, 0, 0, 1, depending on which player has a stored move in that position. And then we have 2 outputs, each 1 bit of H-sync and V-sync. Those 2 just represent basically, like H-sync represents the end of the rows, so where you can no longer exceed after that amount of rows. And then V-sync is just basically the end of the screen completely, and those are both active lows. So once they're at 0, that just indicates that that's the end where the display has to end. And then you also have your 4-bit outputs for the VGA, red, green, and blue. And then, so the first thing you have to do is you have to instantiate the clock divider, because this clock is at 100 Hertz, so you want one that's 25. So you instantiate that module, the clock divider. And then we're going to set parameters for the horizontal and vertical display. So H active is basically all the possible horizontal options, and then H start is where the display that we decide we want to start our display on. So for the grid, we want it to start at HS start, so that's going to be the start, and then HS end is where our display ends, and the row is just basically the total number, and then the same is for the vertical parameters. And then after that, we have H count value, which is 10 bits, and V count value. So those are just basically how we're going to be setting the boundaries. So here we basically set the boundaries through the V sync and the H sync using the same values that we initiated in the beginning, HS start and HS end. And we want to keep it between those 2 boundaries. Then we have an always block that's going to sort of counter for the horizontal and vertical values. That's just basically going to be incrementing through the values of the possible positions that we can have on the display. And then after that, we go into where you see we assign C draw 1 to 9. And this is basically just represents each position on the grid. So we just basically here put our dimensions that we wanted to have for our grid and for each position on the grid. So we just set that for each one. So from position 1 to 9. And then we have the actual grid. So under that, we have grid V1 and grid V2. So that's just the actual grid that we're going to have in white, I guess, to represent the boundaries of our grid. So those are the 2 vertical ones, and those are the boundaries you set for them. And then these are the 2 horizontal ones. And those are also the boundaries you set through H count value and V count value. And then the white grid is basically just an OR of all of those, the horizontal and the vertical. And then after that, this is where we actually display which player has played in which position. So how this works is we're gonna have an always block, obviously, and then we do for the VG, for example, if you look at the first line, VGAR. So what this is saying is that if position 1 is 2 bits of 0, so that means no one has played any move there. So what this function does, the question mark after it, says that if that's true, then we're gonna have 4 bits of 0. So no color is gonna be showing. And then the colon after that shows that you're gonna have the second option, which is position 1 being 0, 1, which means that player 1 played in that position. So that's gonna show 1, 1, 1 for the 4, 1, 1, 1, 1 for the 4 bits of VGAR, which means that the red is going to display there, and then anything else would be 0. So in the third line, for example, of the first block, you see for VGA B, or yeah, in this case VGA B, if it's not position 1, it would just make the green 4 bits of 1. So that would mean that's what would display. So that's basically how that works, and you just do 1 for each position. And yeah, and then all the way to the bottom, and then you just set the white grid. And then at the bottom you have else, you're going to make everything else 0, and then the same at the bottom.
Cool. And the last thing that we're going to talk about is the modules we made to use the RGB LEDs. And these are very simple modules that just take in the clock, the no space value, the winner value, and then it assigns it to a wire. And what it does is every clock cycle, it'll update and check to see whether there's either a winner or if there's no space left. And if there is a winner, it'll check to see who the winner is. So if the winner is 0-1, the lights will turn red. If the winner is 1-0, the lights will turn blue. Otherwise, if no space is equal to 1, it'll indicate there's a tie, so the lights will turn green. Okay, here's the live demo for our project. The first thing I'm going to show you are the switches. Our project uses the first 7 switches, so 0 to 6. These first 2 switches here are used for player selection, so the first switch being up indicates it's player 1's turn. The second switch being up indicates it's player 2's turn. Any other variation of those 2 switches won't do anything. The next 4 switches are used to choose the position on the board, and the last switch is used to enable a turn. So for example, I'm going to place player 1 in position 1, which is the top left of the board. And when I hit the enable, you'll see that there's now a red square in the top left. I'm now going to bypass the player turn order to demonstrate that the LEDs work properly. So I'm going to put player 1 in position 2, which is to the right of where it is now, and then into position 3. And you'll see red has 3 in a row, and the red LEDs turn on. And I can reset the game and do the same thing for the blue player to demonstrate that the blue LEDs will turn on. So we'll put player 2, instead of 3 in a row this way, we'll do 3 in a row this way. So we'll put player 2 in position 1 first, and then we will put player 2 in position 4, and then in position 7. And you see there's 3 in a row, and the LEDs turn blue. Now Harry and I are going to play a game to completion where we're going to demonstrate the illegal move detector and how the game does not let you play in a position that's already filled. And we're also going to demonstrate what happens when the game ends in a tie. So Harry, I will go first. I will play in the top left corner.
Okay, I will play in position 5.
Okay.
So the middle.
So in the very middle, we set it to player 2, choose position 5, and switch. Okay, now it's my turn again. I'm going to try to play position 5. We'll see when I set the switches to player position 5, 0, 1, 0, 1, and I hit enable, nothing happens because that move is already taken. So my move is not yet finished, so I have to choose a new place to go. So I'm going to go in position 2.
Now I am gonna move in position 3.
Okay, so Harry takes position 3, so I set the switches to 3. Player 2, his square pops up. I'm going to block Harry in position 7, so I will set the switches to 7, confirm my turn. Now it is Harry's turn.
So now I am gonna block Kevin and move into position 4.
So we set the switches to 4, and it's player 2. We confirm the move. I'm now going to block Harry and go in position 6. So we set it to my turn. We go and set this to 0, 1, 1, 0, and we confirm the turn.
So now I am gonna move into position 9.
Okay, so we set that to 1, 0, 0, 1. And it's Harry's turn, blue square, and finally I will be going in position 8.
And when he completes this move, you'll see that it will be a tie, so the green RGB should light up.
And that is the live demo for our project.